Hello, fourth graders, Chapter 6 review. As we get ready for our Chapter 6 test, my goal is to encourage you to look through the earlier workbook lessons, look through the earlier and re-watch the earlier lessons based on any challenges that you find or anything that you're having a little bit of a struggle with or you need some reminders. Go back and watch those videos. Look at our notes that we took in a workbook as well. Or certainly ask me in class or on Edmodo. I'm going to try to keep these overviews rather brief. So again, feel free if you're getting stuck. I may not give you the whole problem or the whole answer, the whole process, but I'll give you the big parts of it that hopefully will get you through the entire problem accurately or give you enough to solve the problem accurately with steps 1 through 5. So again, let me know if you have questions. I want to briefly take a look at number 1. We're looking at whether these fractions are equivalent, equal, or not. So keep in mind, there's a number of ways we could compare these fractions to see if they're equal or not. We could certainly do step 2, which is a bar model. But when you're looking at the downside of that, though, is when you're looking at fractions like, or denominators of 16ths or 30ths, you can see that would take you quite a while to draw a bar model with 30 separate pieces, if you will, accurately. So there's probably a better method that we could use, and that would be simply, is the smaller denominator a factor of the larger denominator? Of course, when we say smaller, we mean number-wise, not piece-wise, because we know that 1/4 is a bigger piece than 1/16 would be. But looking at that, we can see that 4 is a factor of 16. 4 times what? Well, 4, let's see if I can write this out here. 4 times 4. Let's use a different color. 4 times 4. And 4 times 4 is 16. And of course, look at the numerator. Is 1 a factor of 4? Indeed it is. 1 times 4. 1 times 4 is 4. So I'll put that above here too. So you can see that 1/4 times 4/4 is indeed 4/16. So these fractions are equal, aren't they? Oops, I didn't mean to circle the not equal sign, but equal there. Okay, you get the idea. So again, for each of these other A, B, C, D fraction comparisons, take a look at the two denominators. Is the smaller one a factor of the larger denominator or not? In the case of D, letter D, we can see that 8 is not a factor of 10. We can also see that 5 is not a whole number. Excuse me, is not an even number. It's an odd number. So we can't. In this case, there's no factor of 5 or 8 that will allow us to simplify. So 5/8 is already written in simplest form. The question is 6/10 written in simplest form? Actually, no, it's not. It's an even. Those are both even numbers. We could actually reduce them down, couldn't we? Is there a factor of both 6 and 10 that would allow us to do that? Well, 2 would work, wouldn't it? If we divide 6/10 by 2/2, we would end up, and I'm going to struggle to have room to write this, but we would end up 6 divided by 2 would be 3. 10 divided by 2 would be 5. So that would reduce down to 3/5, which is not equal to 5/8, is it? This is also, denominator-wise, a smaller enough denominator that you could probably accurately compare 8ths, 1, 2, 3, 4, 5, 6, 7, and 10ths. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oops, I didn't do a very good job of making that even. Let me try that again. And again, an easier way might be actually just to divide it in half approximately, and then put, so that's one line, and then 4 on top would be 1, 2, 3, 4. Oops, I went a little further there, didn't I? And oops, 1, 2, 3. There we go. And then 4 on the bottom. 1, 2, 3, 4. And that should give us 10, not exactly evenly spaced pieces, but close. So as we have 9 lines. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. So yes, so 5/8 is pretty close to 1/2, isn't it? 1, 2, 3, 4, 5. Whereas 6/10 is also pretty close to 1/2. It's a little bit bigger though. 1, 2, 3, 4, 5, 6. You can see just a shade bigger. I wasn't being terribly accurate. I'm sure you could do a better job of that, having a little bit more time on your hands to do that. All right, so there's 2 different methods you could solve for number 1, letter D. On number 2, you're asked to order the ingredients used in the recipe from least to greatest. Well, hopefully this reminds you of our lesson where we talked about comparing fractions on a number line. Real quick reminder, it's going to be a whole lot easier to do that by going ahead and making common denominators where you can, or converting to common denominators where you can. So if this is 0 and if this is 1 whole, there's our number line. You can see here's our halfway point. So there's 1. Let's see. There's our 1/2. Actually, you know what? I'll just do this. So there's our 1/2 mark. So 1/2 cup raisins. If we were to divide this into thirds, we know that, well, 1/3 would be about here. 2/3 would jump us ahead about here, give or take. So it'd be a little bit more than 1/2, wouldn't it? So we know 2/3 would be probably right around here, just estimating. And 3/4 would be a little bit larger than 2/3, and we could prove that by taking the fourths and thirds, as I mentioned earlier, and finding common denominators. I'm not going to do that. I would like you to do that just to prove it. But again, our 3/4 will be placed on the number line. You can finish that, and then 1/4, knowing that 1/4 is less than 1/2. In fact, it's halfway between 0 and 1/2, isn't it? So again, I'll let you finish that problem up independently. Okay, on number 7, in the school course for 24th of the students are 4th graders. You're asked what fraction and simplest form of the students are 4th graders. So simplest form means that we are going to see if there are factors of the numerator and denominator that will allow us to write them as smaller, numerical, smaller numbers. All right, so another word or another term for simplify would be to reduce. So we have 4 over 24, 4/24, and we're going to think what number will divide, or factor would divide evenly into the numerator 4 and the denominator 24. Well, it turns out 4 is divisible by 4, isn't it? And we know that 24 is also divisible by 4. So we can simply divide. When we simplify, we're dividing. And we can divide by 4 over 4. That should work. 4 divided by 4 is 1. 24 divided by 4 is 6. So 1/6 of the students are 4th graders. On number 8, we are asked which pairs of fractions are equivalent. Mark all that apply. Again, that's a hint. Very likely that you're going to be marking more than 1, which is a pair of factors that are equivalent, because they've mentioned that you need to mark all that apply. It's not a for sure, but it's very likely that will be more than one answer there. Keep in mind the earlier part of this video where we talked about how you can draw a bar model, or more likely you can simply find whether one of the fractions will reduce down using a common factor, in just like our example here with 1/6 and 4/24 being equivalent because they were divisible. 4/24 is divisible by 4/4. So again, see the earlier part of the video if you need to review. Number 9. Sam worked on a science fair project for 1/4 hour on Friday and 1/2 hour on Saturday. What are 4 common denominators for the fractions? Explain your reasoning. Well, it doesn't tell us whether we're adding or subtracting these fractions, but for sake of example, let's just pretend that they wanted to know how many hours total Sam worked on a science fair project. Well, we would have 1/4 plus 1/2, wouldn't we? Now, what they're asking, though, be very careful, be focused on the question. They want to know what are 4 common denominators for the fractions. So 4 common denominators between halves and fourths. So what could we come up with for? Well, we know that fourths would work, wouldn't it? Because 2 is a factor of 4. So we could convert 1/2 into fourths, which would be 2/4. So we could rewrite this as 1/4 plus 2/4. In fact, I'm not going to add the plus because they're not asking us to. I'm just going to put a comma. So 1/4, 2/4, and we'll just put in parentheses. We could take both of those and multiply them by 2/2, couldn't we? Which would give us, if we multiplied 1/4 by 2/2, that would be 2/8, wouldn't it? 2/8. And if we took 2/4 and multiplied that by 2/2, that would be 4/8, wouldn't it? 4/8. All right. So keep in mind that we can multiply each of these by, now that we've converted them into a common denominator, a fourth, we can just multiply both those fractions by 2/2. We can do the same thing here. We can multiply 2/8 by 2/2, which would give us 4/16. We can multiply 4/8 by 2/2, which would give us 8/16. I'm going to allow you to finish up the remaining 2 common denominators. I actually just told you could use 16ths. What else could you use? And we're going to wrap up with number 10. So it tells us that Marita works in a florist shop and makes flower arrangements. She puts 10 flowers in each vase, and 2 of the 10 flowers are daisies. Part A. If she makes 4 arrangements, how many daisies does she need? How can you check your answer? All right. So what's the question asking? How many daisies does she need for 4 of these flower arrangements, keeping in mind that for each arrangement she needs 10 flowers total. 2 of them are daisies. So let's go to step 2. Let's draw a picture or make a chart. I think a T-chart would help in this case. And so let's see if we can kind of determine. There's a lot of ways we could do this actually. We could use bar models, but let's start with, let's actually draw a bar model just to clarify it, kind of a picture. So if, in fact, we could use the workspace they give us here. So for one arrangement, there we go. We'll do this. Let's divide this. Since we know we need 4 arrangements, let's divide this into 4 equal parts with 3 lines. So 1, 2, 3. There's our picture. And we know that each of these, we're going to need 10 flowers. So 10, 10, 10, and 10. And here, oh, actually, here's our T-chart right here. And then out of each of those arrangements, here's our flowers total, and then D for daisies. It's kind of like notice the fraction here, 2 out of 10 for each of the arrangements. 2 out of 10, 2 out of 10. So if you look at it this way, this is like a fraction. 2, the numerator, and denominator is 10. So 2 daisies out of the 10 for each arrangement. So we could draw a picture to kind of represent this too. If this is our 10 total for each arrangement, then we have 2 daisies leaving us with 8 other types of flowers for a total of 10 per arrangement. So if that's the case, we need 8 flowers, excuse me, we need 2 daisies for each of the arrangements, and the remaining flowers in each arrangement are number 8. We don't know the types of the other flowers, but that's not important at this point. The question asks, if she makes 4 arrangements, how many daisies does she need? Well, let's count them up. 2, 4, 6, 8. She will need 8 daisies in order to make 4 arrangements with 2/10 of the flowers being daisies. All right. How can you check your work? Well, by checking our work. How do we check? Well, it's here. We have to have work here, don't we? So it's here, and we can, in fact, it doesn't say explain how, it says show how. So here's how we show. We have a picture, we have a chart. Part B. And of course, is 8 reasonable? Yes, it is, because we know that for each of these flowers, each of these arrangements, we only need 2. So 2 times 4 is indeed 8, isn't it? Part B. Last weekend, Marita used 10 daisies to make flower arrangements. How many flowers other than daisies did she need to use to make the arrangements? Okay, explain. So we're going to need to explain below. Now, a couple key terms to be aware of. She used 10 daisies to make the arrangements, and it says how many flowers other than daisies. So she doesn't want to, they don't want to know how many daisies, they already told us. They want to know how many other flowers were needed to make the arrangements. Well, the nice thing about taking the time to show our work on part A is that we can see that we already have accounted for, in the 4 arrangements, we've already accounted for 8 daisies. 2, 4, 6, 8. How many arrangements was that? Well, that was 4 arrangements, wasn't it? 1, 2, 3, 4. So if there's 8 daisies here, that means we only need 2 more, right? So 2 more would mean that we need 1 additional arrangement that we haven't already accounted for. Here are our 10 daisies, 2, 4, 6, 8, 10, meaning that we need to total up the other amount. But keep in mind, we're not totaling up 10s here, are we? This is the total number of flowers is 10. So how many are remaining in each arrangement? Well, 8, because if you take 10 total, take away 2, we're left with 8. So there's 1 arrangement, 2 arrangements, 3 arrangements, 4 arrangements, and then here we would need our 5th flower arrangement, wouldn't we, to make that 5th arrangement. So I'll just write in an 8. Whoops, let me use the other color, red. There's our 2nd arrangement, there's our 3rd arrangement, 4th arrangement, and down below our 5th arrangement. So the question is, how many flowers other than daisies did she use to make the arrangement? Well, how many 8s do we have? 1, 2, 3, 4, 5. And we know that 5 times 8 is 40. So she needed 40 other flowers in order to make the arrangements using a total of 10 daisies. I am out of room, but I'm going to ask you to explain below what we just did. Explain your reasoning. Okay. Thanks for watching, and now our joke of the day. So, here it is. Why did those chickens run away from home? Answer, because they were sick of being cooped up. Thanks for watching. Please let me know if you have any questions about the lesson, and we'll continue in class.